Sir, sir. Good afternoon.
Good afternoon.
Good afternoon, sir.
Okay, we'll continue with the previous topic. We were discussing about omitted measurements, right? So we have 4 different cases in omitted measurement. Number 1, when length and bearing of any one of the leg or traverse leg is omitted, that we have already discussed in the last class. And the second one, when the length of one leg and bearing of other leg is omitted, this was also discussed. And we'll move on to the third case, when the lengths of 2 legs are omitted. It may be the 2 legs may be side by side adjacent or maybe on the other side. Let us take adjacent example. Okay. So this one, length of 2 legs adjacent or omitted. If not adjacent also, we can make it adjacent by drawing parallel lines and all. However, this is not required. How to make adjacent at this level, diploma level. But you can refer BC Punmya, surveying by BC Punmya. There you can see how to make if the 2 legs missing are not adjacent. Then also we can follow the same procedure. Okay, let ABCDE be the closed traverse, and in which lengths of DE and EA both are omitted. Again, you can go through, you can refer this diagram A, B, C, D, E. Among this, both AE, DE, and EA. I'll say DE and EA, 2 lengths are omitted. We know every angle, but length is omitted. Fine. So now, how to proceed? Again, so as these 2 sides DE as well as EA are missing, at the initial we must consider as four-sided traverse like AB, BC, CD, and DA. DA is the closing side of the traverse. So thereby, by applying sigma latitude is equal to 0 and sigma departure is equal to 0, you can calculate latitude and departure of a closing line DA, this dotted line, as well as you can also get the length and bearing of this missing line DA. As usual, we have followed the first case. As in the first case, you can calculate length and bearing of the missing line DA. Okay, once this length is arrived, now as we have 3 angles, again we can apply the sine rule. What is sine rule? Length of the side, let us say length of DA divided by sine of angle between the other 2, that means sine theta 3 is equal to DE by angle between other 2 means sine theta 1 by EA by sine theta 2. So this is a formula in which all the 3 angles are known and one side is known. Then automatically by applying sine theta sine rule, you will get DE as well as EA. The same will be written over here. You can see, yeah. Joint DA becomes the closing line of the ABCDA. Then the length and bearing of DA are calculated as per case 1. Now in triangle ADE, you can go through this. In triangle ADE, right? So in triangle ADE, angle EDA, that is theta 2, and angle EAD theta 1, and angle AED, you will directly get from 180 degrees. Sum of angles in a triangle must be 180, no? So from that principle, you will get all the 3 angles. Now we have to apply the sine rule, as I said. DE by sine theta 1, EA by sine theta 2, and DA by sine theta 3. So in this, DA is known. We have calculated based on case 1, just like here. And all the 3 angles are known. When you equate these 2 terms, you will get EA. And when you equate first and last term, you will get DE. That's all. Okay, now let us solve some problems based on this. When 2 lengths of 2 adjacent lengths are omitted, I'll search for that. Yeah, this one. Example 11 is just like case 3. A closed traverse was conducted around an obstacle and the following observations were made. Work out the missing quantities, that is length of DE and EA. We have to calculate. Okay, so what we are going to do, we need to consider traverse as AB, BC, CD, and DA, where DA is the closing line. So only 3 need to be considered. Fourth line must be DA, and you can calculate sigma latitude and sigma departure. Yeah. So this is a diagram. DA is actually a closing line when you consider the three known traverse sides. The fourth one or closing side will be this dotted line. So here latitude and departure can be calculated by using L cos theta for latitude and L sin theta for departure. How do you get these positive and negative signs? So careful. For latitudes, southings are negative and northings are positive. So therefore, these two are getting positive, and the first one with the south you will get negative. Symbol L cos theta, that means 500 multiplied by cos 98 degrees 30 minutes, or 500 degrees cos 81 degrees 30 minutes. So either way you can do. When you substitute a whole circle bearing directly, the negative sign you will be getting. Otherwise, when you substitute 81 degrees, okay. Otherwise, when you substitute this reduced bearing, sign have to be sign has to be considered by ourselves only. Okay. When you substitute whole circle bearing directly, you will get positive or negative signs directly. Otherwise, you have to search for the south and north as well as east and west. Voice is not clear?
Clear.
Clear, sir.
Okay, good. Actually, I connect mobile hotspot. Maybe okay. But in our college, we don't have internet right now. Some problem is there. Therefore, I need to connect with the mobile hotspot only. Yeah. First step, latitude L cos theta and departure L sin theta. Whereas sign conversions I was talking about, for southings you should put minus in latitudes and northings plus in latitudes. Similarly, for eastings in departure you have to put plus. For westings you need to put minus in departure. Then you calculate sigma latitude and sigma departure. This will be in the just opposite direction. This will be the same magnitude for the missing line DA. Okay, anyhow, if you consider DA as length as L and angle as theta, then latitude will be L cos theta and departure will be N sin theta, and then by applying the sigma rule you can calculate L cos theta of the missing line, that is the DA line, closing line DA, L cos theta, that will be minus 684.53, and similarly L sin theta departure minus 396.34. So based on this, both are minus. That means the quadrant must be southwest. Things, latitude minus means southing, and similarly departure minus means west. So, since both latitude and departure are negative, the line DA is in the third quadrant, that is southwest quadrant, and length and bearing can be calculated. Yeah, we have discussed in the last class also. Length can be calculated by this formula, under root of sigma L square plus sigma D square. When you substitute all these in this formula, you will get directly the length. Similarly, for theta, tan inverse D by L, D departure by latitude. When you calculate this angle, you will be getting as 30 degrees 4 minutes. So therefore, it is in the southwest quadrant. Therefore, south 30 degrees 4 minutes and west. And you can also convert it into whole circle bearing. Again, you have to go through the whole circle bearing and quadrantal bearing in compass array. 1 minute. Madam, namaste. Cheppandi. EDP? Okay, madam. అది కన్ఫర్మ్ అయిందా మేడం? ఎగ్జామ్ టైం టేబుల్ సరే సరే 5th నుంచి. ఓకే మేడం, నేను ఫస్ట్ నుంచి నాకు ఎంటెక్ క్లాసెస్ ఉన్నాయి. నేను ఎంఈ మాడ్యులర్ జాయిన్ అవుతున్నా. సో నేను ఉండట్లే మేడం, ఈడీపీలో కూడా నేను ఉండను. లేదు ఇప్పుడు చేస్తా మేడం, ఫస్ట్ తర్వాత ఉండను. ఇప్పుడు నేను ఏ వరకు ఉన్నా ఇప్పుడు నేను చేస్తా, ఫస్ట్ వరకు నేను చేస్తా. ఫస్ట్ నుంచి నా క్లాసెస్ ఉంటాయి. అప్పుడు మేబీ ఎవరైనా సబ్స్టిట్యూట్ చేస్తారనుకుంటున్నాను, ఎందుకంటే మాకు డే అంతా క్లాసెస్ ఉంటాయి కావచ్చు. మాకు 33 days ఉంటాయి మేడం, డిసెంబర్ మంత్ మొత్తం అయిపోతుంది. అదే మేడం మీకు చెప్తారు ఎవరినైనా ఒకరిని. మా హెచ్ఓడి మేడం ఆల్రెడీ ప్రపోజ్ చేశారంటే, కల్పన మేడం ఉన్నారు కదా ఫార్మసీ, ఆ మేడం ఉంటారు ఈడీపీకి. అండ్ శశిధర్ రెడ్డి సార్ ఉంటారు. నా పేరు పెట్టిరా మేడం? నేను 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 మాట్లాడతానండి. నాకు పంపిస్తే నేను లెటర్ నేను మాట్లాడతాను. ఇప్పుడు ఇంతకు ఎందుకు వేశారు మేడం? ఇప్పుడు ఎందుకు వేశారు? అట్లా అంటలే మేడం. ఇప్పుడు నాకెందుకు చేశారు కాల్? ఏం కనుక్కుందామని? ఈడీపీ పాస్వర్డా? మరి నాకు ఎంటెక్ డ్యూటీ ఉంది మేడం. నేను మాట్లాడతానండి. మీరు లెటర్ పంపించండి, నేను ప్రిన్సిపల్ మేడం దగ్గరికి వెళ్ళి చెప్తా. ఇవాళ వచ్చారు కదా మేడం? సరే సరే మేడం. సరే సరే మేడం. ఓకే మేడం. థ్యాంక్ యూ. ఆన్లైన్ క్లాసులు మేడం. ఎస్. ఆర్ యూ దేర్ స్టూడెంట్స్?
Yes, sir.
Yes, sir.
Fine. So up to here, we are actually finding the length and angle of the closing side, that is DA. So having obtained this length and bearing, then we'll use this triangle DEA, and from this triangle, by applying sine rule, we are going to calculate the missing lengths DE and AE. EA, okay. AE or EA both are same. Right, fine. Up to here, we got the length of DA as well as bearing. Then to get theta 1, you can go through this figure. Theta 1 is nothing but the angle over angle in this triangle, angle EAD, right? So angle EAD, let it be theta 1. How to calculate theta 1? Theta 1 is equal to, you know, the forebearing of DA. Okay. Yeah, this one. Theta 1 is equal to 360 minus back bearing of EA. Okay, I'll try to draw. Right. Actually, I need to zoom in. Fine. Okay. So this is back bearing of forebearing. Okay, EA, right? Back bearing of EA, isn't it? So this is back bearing of EA, and from this projection of north line to up to here, this small angle is nothing but forebearing of AD. Okay, so then how to get theta? So theta 1, simply when you subtract from 360 this back bearing, you will get the leftover portion, this small portion, and this is to be added to the adjacent one. So then only you will get the theta 1. Is that okay? Have you understood how to get theta 1?
Yes, sir.
So we are actually having two quantities. Back bearing of line EA is nothing but just I have drawn with the blue one in blue ink, and let I also draw the second angle. Yeah, these two angles are known. With the help of these two, you are going to calculate the theta 1. Okay, so total theta 1 is a total angle measured from EAD, angle EAD. So this angle over here is to be added to the red color, so that you will get the total angle theta 1. So how do you get the yellow marked angle? Total circular angle is nothing but 360. From 360, when you subtract the back bearing of EA, you will get the angle marked with the yellow color. Then you can simply add these two to get the theta 1. The same thing applied over here. Okay, clear. Fine. We'll go back here. Theta 1 is equal to 360 minus back bearing of EA plus forebearing of AD. That is, when you add total, you will get 59 degrees and 54 minutes. Similarly, angle ADE, that is theta 2. Angle ADE is theta 2. Again, I need to. It is just a repetition of your compass surveying only. Fine. This entire angle is nothing but the forebearing of line DE. isn't it? This angle marked in yellow color is a forebearing of line DE. And when you project this line, I'll change the color. Okay. Now the angle marked in red color is nothing but the okay. When you measure in quadrantal bearing, it's a bearing of DA, or otherwise I'll mark with the red color from the north direction. So this is a bearing of the line DA. Okay, so forebearing of line DA. So to get theta 2, simply we need to subtract this red color from the yellow color. That's all. So theta 2 is equal to bearing of DE minus bearing of DA, that is 19 degrees 56 minutes. When you get the two angles, third angle must be sum of angles in a triangle must be 180. So therefore simply when you subtract from 180 these two angles sum, then you will get the third angle, let it be 100 degrees. Now you know the three angles, then from applying sine rule, side DA divided by sine of theta 3 is equal to side EA divided by sine of theta 2 divided by DE by sine theta 1. This is sine rule. Any one side divided by sine of angle between other two is equal to other side and continuous. Okay. So by applying sine rule, DE is equal to sine theta 1 by theta 3 into DA, and EA is equal to sine theta 2 by theta 3 into DA. So when you substitute values over here, you will get the direct missing lengths DE as well as EA. Is that clear?
Yes, sir.
Okay, have you understood this problem? How to solve missing quantities or omitted quantities when the two adjacent sides lengths are omitted? Okay, we'll try to solve one more problem. If it is there, I'll search. No, this is not the case. This is again area problem, consecutive coordinates. Find the area of the closed traverse given independent coordinates of our traverse stations A, B, C, D as 0, 10, 10, 20, 20, 10 and 10, 0. Again, yesterday's class, y1, x1, y2, x2, y3, x3, y4, x4, and again you need to write at the last also y1, x1. Then like this, y1 half into y1, x2 plus y2, x3 plus y3, x4 plus y4, x1 minus x1, y2, x2, y3 minus x3, y4 minus x4 and y1. When you calculate like this, you will get the total area. You can omit this negative sign because area will always be positive only. You won't get negative area anywhere. Okay. Again, this is independent coordinates, area calculation. What is this? Again, it's area. Okay. I don't have one more problem similar to the both lengths are missing. But we'll move on to the fourth case and last case in omitted measurements. That is when two bearings are missing. Yeah, here. When the bearings of two legs are omitted. Okay, again we are going to use the same triangle and same diagram. Yeah. Bearings of two legs, let us say adjacent, are omitted. Then how do you calculate the required angles? Let A, B, C, D, E, A be the closed traverse in which bearings D and E are omitted. Then area of the triangle is equal to S into S minus D minus S minus E. Multiply by S minus E, S minus A. I don't think this is required. Wait a minute. We'll go to the problem based on this. When two bearings are omitted, yeah, like this. Okay. Rajkumar, pharmacy HOD, sir. అవును ఫార్మసీ హెచ్ఓడి సార్ అటు సైడ్ ఉంటారు. హెడ్ ఆఫ్ ఫార్మసీ అని రూమ్ ఉంటుంది. ఒక్క నిమిషం సార్ కాల్ చేసి 1 minute అమ్మా. అమెజాన్ ఏంటది? అమెజాన్ సార్. ఓకే. హెడ్సెట్ అనుకుంటా. సార్ మీకు అమెజాన్ హెడ్సెట్ వచ్చింది. ఎక్కడ సార్? ఆన్లైన్ ఫోన్ పే చేస్తా. ఓకే మాట్లాడండి. మాట్లాడతారా సార్? సార్ మాట్లాడండి. హలో సార్ చెప్పండి. ఓకే ఓకే సార్. ఫోన్ పే చేసారా? చేసారా సార్? గూగుల్ పే నంబర్ 7416. QR yes. One more double yes. 7600. Sir. 147. Yes sir. 1488. Local bill sir. We only for tracking కోసం. Thank you sir. Okay, right. Are you there?
Yes, sir.
Okay. So in the starting derivation part, he has used the area of triangle formula, but I think that is not required. You can use the cost rule to calculate. I'll skip this one and I'll explain while I'll solve the problems for the fourth case. Right. So this is a problem where in a closed traverse ABCD was conducted around an obstacle. Due to obstruction, it was not possible to observe the bearings of the lines BC and CD. Calculate the missing bearings. So this is a problem. AB, BC, CD, DA is a closed traverse, and in which bearing of BC and CD are missing. Now, since the bearing of two consecutive lines BC and CD are missing, join BD by a dotted line. Is there any? Yes. This is a diagram AB, BC, CD. In which BC and CD are omitted. So bearings of BC and CD are not there. Therefore, we need to omit these two. As in the first case, we need to omit the two required lines. We should consider the whatever values there. That means for AB line, length and bearing is there. You can calculate latitude and departure. So you should consider AB as well as DA also. For DA also we have length and whole circle bearing. Bearing. So with the help of these two, we can calculate latitude and departure. So let us consider only two lines AB and DA. When you consider AB and DA two lines, then the closing side will be DB or BD. Okay, this will be the closing side. So based on again first case, that means sigma latitude must be 0, sigma departure must be 0. You can calculate the length and bearing of the closing side BD. Okay, here let the length and bearing of BD will be L and theta respectively. Then the latitude and departure of a closing light can be calculated as follows. Sigma L is equal to 0. When you apply this equation, L cos theta is the only unknown and you can calculate this. And similarly, when you apply sigma D is equal to 0, again L sin theta is the only unknown. You can calculate L sin theta. Once you know L cos theta and L sin theta, from this to calculate L, you need to apply this formula, a square root of sigma L square plus sigma D square. and when you substitute, you will get the length of the closing side. Similarly, for calculating theta, tan inverse d by l, in this formula you need to substitute, and you will get a angle as some 19 degrees 2 minutes. So as both latitude and departures are negative, no, it is positive, right? Okay, then it is southeast quadrant. Departure is positive, therefore east. Latitude is negative, therefore south. It must be in southeast quadrant. Okay, then now in triangle BCD, we'll go back to this diagram. Triangle BCD, you can see triangle BCD in this diagram. Let us calculate the thetas in the individual angles. Now in the triangle ABCD, the lengths of three sides are known. Hence, the included angles theta 1, theta 2, theta 3 can be found by applying cosine rule. What is cos rule? If anybody remember, cos theta, let us consider theta 1. Okay, cos theta 1 is equal to the two adjacent sides. That means BC square plus BD square minus 2 into minus BC square. I'll explain the other way. CD required length, let us say CD square is equal to BC square plus BD square minus 2 into BC into BD into cos theta 1. So from that, all the three sides are already known to us, only theta is unknown, and then you can calculate the required angle. Okay, the cos theta 1 is equal to adjacent squared, one of the adjacent side square plus the other adjacent side square minus opposite side square divided by 2 into 2 adjacent sides is equal to cos theta, and from this you can calculate the theta 49 degrees 59 seconds and 48 minutes. And similarly, ఎవరు రాస్తున్నారమ్మా ఇది? క్లాస్ చెప్తుంటే రాయడం కరెక్టేనా? నేను అప్పుడప్పుడే క్లాస్ చెప్పేది, అది కూడా బోర్ అయితే ఎట్లా మీకు? Okay, so similarly when you apply cost rule for the other side, cos theta 2 is equal to again 1200 square plus 880 square minus 1004.971 square by 2 into 1200 into 180. Sorry, 880. ఇదేమన్నా ఫార్ములా ఏమైనా డౌట్ ఉందా ఎవరికైనా? కాస్ట్ రూల్ మ్యాథమెటిక్స్ లో ఆల్రెడీ వచ్చి ఉంటది. కాస్ట్ రూల్ ఏమైనా కన్ఫ్యూజన్ ఉందా?
No doubts.
No,
sir.
sir.
Okay then, good. So ఇందులోంచి మీరు theta 1 and theta 2 వన్స్ రెండు యాంగిల్స్ వస్తే ఆటోమేటిక్ గా 180 మైనస్ theta 1 and theta 2 చేస్తే ఆటోమేటిక్ గా థర్డ్ యాంగిల్ వస్తుంది. లేదంటే మళ్ళీ కాస్ట్ రూల్ అప్లై చేసి కూడా చెక్ చేయొచ్చు మీరు. ఓకే, సో లైక్ దిస్ యూ కెన్ క్యాలిక్యులేట్ ద మిస్సింగ్ టూ బేరింగ్స్. సో విత్ దిస్ వీ హ్యావ్ కంప్లీటెడ్ ఒమిటెడ్ మెజర్మెంట్స్. ఏమైనా డౌట్ ఉంటే చెప్పండి. ఒమిటెడ్ మెజర్మెంట్స్ లో ఉన్న ఈచ్ అండ్ ఎవ్రీ ప్రాబ్లం మీరు సాల్వ్ చేయగలగాలి. 4 కేసెస్ ఉన్నాయి. ఏ ప్రాబ్లం ఇచ్చినా కూడా ఈ 4 కేసెస్ లో ఏదో ఒక కేసు ఉంటుంది. ఓకే, okay then, thank you one and all. I'll close this session here. Next class లో మళ్ళీ వేరే టాపిక్ తో స్టార్ట్ చేద్దాం. థ్యాంక్ యూ.
Thank you, sir.
Thank you, sir.
Questions, CR.
Thank you, sir.
Yeah, thank you.
Okay.